this. All right, so we will start recording now. I will have the replay available for viewing on my YouTube channel. So yeah, let's get to it. So in her absence, I am going to do the math that I know how to do that will best benefit you in school and on your dosage calculations journey, which I deem would be fractions, decimals, and rounding. Okay. So we will go ahead and start with some of those things. Alrighty. So fractions. Everybody does not like fractions. But fractions, they don't need to be as hard as we make them. Honestly, we know that we have a numerator, which is the number that's at the top, and then your denominator is the number that's at the bottom. So the denominator represents the whole of the pieces that's broken up. So if you have one whole cookie, you have 4 pieces that is divided into. So that's your fraction, okay? So in order to convert a fraction to a decimal, all we're gonna do is divide the top by the bottom, the numerator by the denominator. So in this case, all you would have to do would be divide 3 by 4, and you would enter it into your calculator, and you would get 0.75, okay? Simple. But sometimes we all need a kind of refresher, okay? And if you have questions along the way, feel free to put them in the chat too, so I can reference them at the end and try to best answer your questions, okay? All right, so now go back. All right, let's convert some fractions. So right here, we have a mixed fraction. So when we have these in our dosage calculation problems, like 7 3/4 cups, and we need to convert them to milliliter or teaspoon or whatever you have, sometimes you might see fractions in your grains to milligram problems. You might freak out because, oh, it's a big number and it's a fraction. So we call that a mixed fraction. So you can't do anything with the mixed fraction. You need to have an improper fraction. So that means that you're going to have a big number on the top and the same denominator on the bottom. So the steps to doing to converting a mixed fraction to an improper fraction will be to take the whole number, which is that big number that's on the left, and you multiply it by the denominator, which is at the bottom. So you would do 7 times 4, which would be 28. And then you add your numerator to that number. So the 28 plus 3 equals 31, and your denominator remains the same as the original fraction. And that's going to represent the whole number of the equal parts, which is the whole is divided into. So our final answer would be 31/4. So we're going to do a couple of these and let's practice, and I'll show you exactly what I'm talking about. All right, so make sure we can see this. All right, y'all let me know in the chat. Can you see my whiteboard? Sorry if I missed this, but will this be sent? Yes, it will be recorded. Okay, everybody can see the whiteboard. Awesome. So if we had a fraction and it was 10 and 3/7, and we needed to make this a mixed fraction, right? Well, from a mixed fraction to an improper fraction, what we would do is take the big number and you multiply it by the numerator. So that number right there, right? So we'll do 10 times 7, which will equals 70. And then you add this number to this number. So plus 3. So that will be 73. And then you keep the bottom number. Okay, so you put everything over that bottom number, which is your denominator. So I kind of get numerator and denominator confused sometimes. So just think down. Denominator is down, okay? And so your final answer will be 73/7. Okay? Prince, you don't see what I'm writing? Oh no. Let's see here. Can anybody else not see what I'm writing? I see. Okay. Well, let's see. I will try to start it back again. Okay. Everyone should have access to the whiteboard. You see the whiteboard now. Okay. So let's do another one. So what did we had? 8. I don't like how it looks. And 3/4. Okay. So what we'll need to do is take the whole number, which is 8, and multiply it times the denominator. So 8 times 4 is going to be 32, right? And then we're going to add the top number, which is the numerator. So that's going to be 32 plus 3, which will be 35. And then you put it over the denominator. The denominator stays the same. So it'll be 35/4. Say that 10 times fast, okay? Let's do one more for good measure. Let's say 11 and 3/5. Okay, so we have 11 and 3/5. We want to multiply this bottom number by the 5 in by your 11. So that's your 11 times 5, which will be 55. And then we want to add the top number, which is your numerator. So plus 3. So that's going to be 58, right? Fifths. That's your answer. 58/5. Okay. So it's easy peasy, lemon squeezy. You just kind of have to have a reminder sometimes, right? Because I know before nursing school, it had been a long time before I used a lot of these math skills. Okay, so here is how you would convert a decimal to a fraction. Okay, so if you have your decimal, what you want to do is identify the place value of the rightmost digit in the decimal, and you use that as the denominator in the fraction. So you know you have your tens place, then you have your hundreds place, then you have your thousands place. Okay, so this 5 is going to be in the hundreds place, so our denominator is going to be 100. So then you would multiply the decimal by the denominator to get the numerator, and then you're going to simplify it if you can. So since we have 100 as our denominator, we're going to multiply that by 0.75, and we get 75, and we'll put 75 over 100, which is further broken down to 3/4. Okay, so let's practice some of those. If everyone has Texas Instrument calculator, it will do the work for you. Oh, shoot. So Texas Instrument one time for the one time, okay? All right. So if we have, let's see, 0, 0.0 3, 4. Am I just doing fractions tonight? No. So Jodeci, if you missed it when I first came on, Jakara Lewis, she is the Tease Test Math Prep GOAT. She is unable to join us. She was supposed to be doing this first portion tonight with her math expertise for HESI, Tease, all other kind of math basics. So this is just what I came up with on the fly to kind of get you prepped and ready for the dosage calculations part. So this is just the basic math that you would find beneficial for the dosage calculations. So dosage stuff is coming up real soon. This is just kind of the prerequisite to kind of refresh you on some of the skills that you would need, okay, that you would see that come up. All right, so we have 0.34. All right, so the rightmost place value is the hundreds. So we know that our denominator is going to be 100. So then we'll times this number by 100 and we'll get 34. So we'll place 34 over 100. And so what is the common denominator or some factors that they share that you can simplify this down? Can't be 3, can't be 4, so it's got to be 2, right? So 34 divided by 2 is going to be 17, and then 100 divided by 2 is going to be 50. So this will be your fraction reduced down to the lowest term. Can everybody see my whiteboard? If you cannot, please say so in the chat. I want to make sure that everybody is coming along. No troll left behind. All right. So let's do one where we have the place value. We cannot see. No, don't say that. Okay, let's see. Stop share. Share content. All right, can everybody see this screen? Yeah. Okay, maybe it was the whiteboard that was dysfunctioning. Okay, so I'll use this instead. No, Wes? Oh no. Let's see. Charlene says no as well. Okay, so let's see what we'll do. How about now? You're good. I could see it first, but now I can't. Is everybody good? Yep, yep, yep. Okay, awesome. All right, so we'll do it this way. That's fine. So this part right here is the rightmost, okay, digit. So that is your thousandths place because we have tens, hundreds, then thousands, right? So we'll put 1,000 as our denominator. All right, so now we'll have to multiply this by 1,000. So if you multiply 0.555 by 1,000, that's going to give you this, right? So if we broke this down by what, fives? What would that be? Divided by 5. 111. And then divided 1,000 by 5, it would be over 200. So that is the broken down fraction. So you see with your fractions, All you have to do is go to the rightmost number, and depending on which place value, that determines your denominator. And remember, denominator down, numerator is going to be on the top. Okay, so then you multiply it by your denominator, and then you get your numbers, and then you just break it down further as you can, as with the common terms. Okay. All right, moving on. So rounding is a big part of dosage calculation. Most of the time, it will tell you in your directions, in your instructions on how they want you to round. The most common places that they want you to round would be to the whole number, the tenths, or the hundreds, especially with pediatrics, because you have to have those really specific numbers with their weights and with their the dose that they receive. So whole number is everything to the left of the decimal. The tens place is that first spot, the hundreds place, and then the thousands place. All right. So what you want to remember with rounding is round right. So what you want to do is start at the place that it tells you to round. So if it tells you to round to the whole number, we're going to look at the whole number. If it tells you to round at the tenths place or to one decimal place, then you start at the tenths place, and then you're going to go one decimal place to the right. If that number that is to the right of what you're looking for is 4 and below, it's a no-go. That means that you are going to round it to anything, and everything that is behind the number that you're rounding to has to go. And that is your answer. However, if that number is 5 or more, then you raise the score by 1, and then everything after that number is gone. So let us go ahead and do this one. So 53 0.362. Okay. So if we wanted to round to the whole number, we would start at your whole number. Then you go one decimal place to the right, which is going to be this 3 right here. If it's 4 or more, 4 or below, it's a no-go. So that means this number right here is going to stay the same, and then all of the other numbers will disappear. Okay. And that will be your answer. So once again, if we were to round this number to the tenths place, we'll start at the tenths place, and you go one decimal place to the right. Okay, that number is a 6. So if it's five or more, we raise the score. So that's going to be 53, and then we raise this one by 1 point, right? So one digit, so 0.4, and then the rest of it falls off. And so this would be your answer. Okay. If this asked us to round to the hundreds place, we'll start at the hundreds place. You go one decimal place to the right. Remember to round right, okay? And this is a 2, so it's 4 and below, so it's a no-go. We're not going to increase it. We'll just do 53.36, and then the rest of the numbers are gone. And that is your answer, rounded to the hundreds place. Does anybody have a question about rounding to the whole number, to the tenths, or to the hundreds place? Okay. So now we'll get into the dosage part. This is me. This is me. This is me in my element, okay? This is my baby, and I'm excited about it because what I don't want you to be afraid of is dosage calculations. I believe that if you have some common concepts and basics down, then dosage calculation can be easy as putting puzzle pieces together, okay? So what I heavily suggest to you if you're starting or you're in school is to choose one method because there are several. You have dimensional analysis, you have ratio proportion, and you also have desire over half / formulas. Tonight we'll be going over dimensional analysis. I choose to heavily push dimensional analysis because you can do dimensional analysis for almost all of your dosage calculation problems, and you can do it the same way for all of them. Okay. The only thing that we have to know are a couple of rules. Okay. So you got to memorize your metric and your household conversions. There is no way around it. You've got to memorize those, but I can show you kind of some tips and tricks or how you can group them together so that they make more sense and that they can kind of stick with you. B, you've got to label your units. So the math was going to math at the end, okay? What we are going to be doing is lining up our units, or I like to call them puzzle pieces. What's on the bottom has to go on the top and they have to cross out. How do we know what to cross out without labeling them? So if you put numbers, you might get confused. You've got to label your units. I said, I'm doing ABCs. So I guess C, respect your relationships and your puzzle pieces. Keep them together. Things that belong together, stay together. In real life, if you have a puzzle piece or you have puzzles and they fall out on the floor and you're trying to put them together, do you break them to kind of make them fit how you need them to fit? No, that's a puzzle piece. It stays together. And what I mean by puzzle piece or relationships is think about it as things that belong. So 1 hour is 60 minutes. We know that 365 days is in a year. All of those things that equal each other in the problem. If you have milliliter per hour, milligram per milliliter, those are the things that are puzzle pieces and they have to stay together. Microgram per kilogram per minute. That's 3 different elements, but they're all on one puzzle piece and you keep them together. Don't break them up, and you can only use one puzzle piece one time. Okay. Everything on the top has to cross out with what's on the bottom, except for that picture on that puzzle box, which is our goal. And that's the first thing that we do after we read the problem. We identify the goal, and anything over 1 is going to be itself. You over 1 are what? Yourself, right? So just like I said that we have puzzle pieces and we can manipulate them, A over B equals B over A. It's going to be the same puzzle piece no matter which way or how you set it up or rotate it or fit it together. That is one puzzle piece and it is the same, okay? All right, so metric conversions. So we've got some common ones. The weight, you will always have to know that 1 kilogram is 2.2 pounds. Know it, love it, eat it, okay? I've got these listed on my website on cheat sheets, that same website that you use to sign up for the webinar. So if you want to print those out, you can write on them, share with your friends, whatever. Okay, 1 pound is 16 ounces. And then there's another one for grams, which is 454 grams. And it's not as commonly seen as your pounds and ounces or your pounds and kilograms. We know that for length, you've got 1 inch is going to be 2.5 centimeters or 2.54. It just depends on which system of measure that your program uses. But that is for your inches. And then for your feet, we know that there are 12 inches in a foot. Now, household, that's with your teaspoons, your tablespoons, your ounces, and your cups, pints, quarts, and gallons. So I have a nifty little video on my TikTok that is pinned to the top of the page, okay? It's gone to a little song, and if you know it, then you know it. If not, it's still gonna help you, okay? So 1 tablespoon, 1 teaspoon, and then 1 ounce. So we know that we put a teaspoon on top of a table, right? That's going to help you kind of memorize which one is larger than the other one. So the teaspoon goes on the top of the table. The table is bigger than the teaspoon. So 5 15, 30. Teaspoon, tablespoon, ounce. 5, 15, 30 mLs, okay? And then 1 cup is 8 ounce, 2 cups is 1 pint, 2 pints is a quart, and then 4 quarts is a gallon, okay? Now, with your King Henry diet by drinking chocolate milk, that is a nifty little mnemonic to remember all of your place values because they're all separated by factors of 10, but the ones that you will commonly use in dosage calculations will be the kilo, of course, base unit, your milli, and your micro, okay? And you see how all of these are 1,000 factors. So your base unit is 1. So if you go to milliliter, that is 1,000. So if you have a 1 gram size cookie and you broke it into a whole bunch of little crumbs, it would take 1,000 little milligram crumbs to come together to give you a 1 gram cookie. Just like if you have a 1 milligram size cookie and you broke it down further, then you would have 1,000 little microgram crumbs to come together to make a milligram. And then we have the kilo, the big kahuna, right? If you have a kilogram size cookie and you broke it down, all those not puzzle pieces, all those crumbs of that cookie would be 1,000 grams. So I hope that this kind of diagram can help put it in perspective for you and help you remember that they're all factors of 1,000. 1 gram equals 1,000 milligrams. 1 milligrams equals 1,000 microgram. And then 1 kilogram is 1,000 grams. And these are the most common ones that you're going to use in your dosage calculation problems. So after you finish that first initial test that shows you know how to convert your metric system problems, then you won't see hecka and deci and deca. You'll see kilo, milli, and micro, and they are all 1,000. Okay, so your temperature, we have your Fahrenheit, which is going to be your Celsius, your degrees Celsius times 1.8, and then you add 32, and then your Celsius will be your Fahrenheit, your degrees in Fahrenheit minus 32, and then you divide that by 1.8. So in pediatrics, you most likely will see a BSA. BSA stands for body surface area. So you have 2 formulas that you will have to remember for those. There's no getting around those. Like I said, for dimensional analysis, you normally can just get by with your conversions, but there are some exceptions and you will have to know the BSA formula, but it's an easy one. So basically it's the weight times the height divided by either 3,600 or 3,131, and you take the square root. It just depends on if you're using the US measurements or the metric system, okay? All right, so how we set up these problems, is that a issue for anybody? If you are confused on what to set up, where to set it up, where to start, and how to get through these problems, put a 1 in the chat. Okay, so I see a couple of people putting 1 in the chat. So what we're going to do is we're going to do these problems the same way every single time, the same way. So what we'll do is we'll read the problem, we'll identify the goal, and that is, what is this question asking you to find? Is it milliliter? Is it milligram? Is it milliliter per dose? Is it milliliter per hour? Is it tablets per day? Is it tablets times 10 days? Whatever that question is asking you to find, that is going to be our goal, okay? Step 2, you're going to write out your puzzle pieces, which are going to be your relationships that I had mentioned, okay? And you would write those to the side. Now, in my big experience in 14-year wisdom, I still write my puzzle pieces to the side. I feel like when you have a problem and you have a lot of things going on in the problem, it's easy for you to get lost or confused or even overwhelmed. So if you know you've got the puzzle pieces that you're going to use in your equation, go ahead and put them to the side and then cross all of your other fluff out. We will use our goal to determine what are we going to use and what is deemed fluff, okay? And then step 3, start with what you're looking for. And that's going to be the first thing, and it's going to be on the top. So if we're looking for milliliters, we're going to start with milliliters. If we're looking for milligrams, we're going to start with milligrams. If we need milliliter per hour, I'm still going to start with my milliliter on the top until I work my way through and then get hour on the bottom. I'm going to align my puzzle pieces. What's on the bottom has got to cross out with what's on the top, and you continue this until all of your units are crossed out except for the goal, okay? Step 5, we're going to multiply across the top, then we're going to multiply across the bottom, then we're going to divide the top by the bottom, and then we're going to make sure that we label our answer because we don't have time to not get these answers right, okay? And let's start because we will do about 5 to 6 different type of problems and practice with them on different types of metric and household conversions, tablets, IVs, heparin, weight-based. And so you can see how dimensional analysis will work in those circumstances, okay? All right, so let's practice. We have 10 milliliters and we want to make that ounces. So I would get my trusty board here. All right, so we want 10 milliliters and we want to go to ounces, okay? So I am going to write my goal. My goal is what I'm looking for. I am looking for ounces, okay? So then I'll write my puzzle piece to the side. These are going to be my metric conversions that I know, okay? So I know that we are looking for milliliters. So I've got to have some puzzle pieces that go from ounces to milliliters and have milliliters in them. So we do know that 1 ounce equals 30 milliliters, okay? That's a direct conversion, and that's the only one that we're going to need because we have both milliliters and ounces, okay? So if I'm looking for ounces, I'm starting with ounces. So I'll put that first and I'll put it on the top. So 1 ounce is 30 milliliters. Now I have milliliters on the bottom. So I want milliliters to go to the top. So I'll use my milliliters from the equation and I'll put it on the top. It's not with anything. It's not in a relation to anything. It is just 10 milliliters. So we'll put it over 1 because anything that is over 1 is going to be itself. Okay? Your milliliters cross out, and then you're left with just ounces, right? All right, so now we'll multiply across the top, which will be 10 times 1, and then 30 times 1 on the bottom, and then we'll divide the top by the bottom, and then we shall get 0.33333 repeating. All right, so this is your time to shine. Remember, we did our rounding at the beginning of the session. If we were to round this to the 10th place, y'all let me know in the chat, what do you think our answer would be if we were rounding to the 10th place? I see 2 answers, and they are right. So that's 0.3 ounces, okay? So we had another question. It was 2 cups equals how many mLs, okay? So what is our goal? Our goal is milliliter, all right? So if we have our puzzle pieces, what will they be? I know that 1 cup equals 8 ounces. I don't have milliliters yet, so I know that 1 ounce is going to be 30 milliliters, okay? If I'm looking for milliliters, I'm going to start with milliliters. So this puzzle piece has my milliliters in it, and I'm going to use it. I'll put my 30 milliliters on the top over 1 ounce. I have ounce at the bottom, so now I need ounces to go at the top. I'll use this puzzle piece right here, and I'll do 8 ounces is 1 cup. Ounce crosses out, and now I've got cups at the bottom. So then I'll use my cups from here, which is the initial question, and I'll put it over 1 because it's not with anything else. It's just by itself, right? And so now I can multiply across the top, multiply across the bottom, and then divide. So we'll do 30 times 8 times 2, which is going to be 480 over 1. So that'll give us 480 milliliters. So you see how everything crosses out on the bottom, on the top, except for your goal, which is right here. You start with what you're looking for. You don't have to go and find it, okay? So let's do a microgram to milligram. So 175 micrograms equals how many milligrams? So we know that 1 milligram equals 1,000 micrograms. So we'll do 1 milligram over 1,000 micrograms. I got micrograms at the bottom, so I'll put micrograms at the top. 175 micrograms over 1 crosses out, and then you have milligrams, which is what you're looking for. So you do 175 divided by 1,000, and that's going to be 0.175 milligrams. Okay. And let's see. I'll do one more. So let's do pounds and ounces to kilograms. So if you have 15 pounds and 4 ounces, we want to know how many kgs is that, right? So that would be changing everything to pounds, because we know that 1 pound equals 16 ounces. And then we know that 1 kg is 2.2 pounds, right? So we have to change everything to pounds because we can't do ounces and pounds to kilograms. So what we'll do is we'll convert our ounces to pounds, and then we'll add everything together and then change that to kilograms. All right. So what we'll do is 1 pound is 16 ounces times 4 ounces over 1. Pounds crosses out, and then you'll have 4 divided by 16, which would be, I think it's 0.25. 0.25 pounds. You'll add your pounds together. So we have 15 pounds already. So we'll do 15.25 pounds. And then we'll do our 1 kg is 2.2 pounds. And then we have our newly found weight. It's by itself. We'll cross it out, and then we can divide the top by the bottom and get 6.93 kgs. Okay. All right, so how will we use dimensional analysis with oral tablets and liquids? So we'll have the doctor ordered 1,500 milligrams of a medicine by mouth to be given in 3 equally divided doses. The medicine is available in 250 milligram tablets. How many tablets should be given for 1 dose? Okay, so what we are looking for in this problem, can anybody tell me what the goal would be? milligram. So it'll be tablet per dose. So we want to give it everything that it's asking for, and that's it. Tablets per dose, right? So we'll set it up. So our goal is going to be tablets on the top and dose on the bottom. So in the problem is that we had ordered 1,500 milligrams, and that is for one dose. And it was to be divided into 3 equally divided doses, right? So if you had 1,500 milligrams, that's in a day, you have to divide it into doses. You have 3 doses in that day. And then in your tablets, you had 250 milligram tabs. Okay. So we're looking for tablets or tabs. We'll start with what we're looking for. So I'm going to flip this over and I'm going to put it at the top. So in one tab, you've got 250 milligrams. I've got milligrams on the bottom, so I need milligrams at the top. So that'll be this one, okay? 1,500 milligrams that you would give in one day. Your milligrams crosses out, and then in one day, we are to give 3 doses. So they cross out as well. So now you have tablet per dose. So that is what you're looking for. So now you can multiply across the top, which is going to be 1,500, and then multiply across the bottom, which is 250 times 3, which is going to be 750. And then you'll divide the top by the bottom, which would be 2 tablets per dose. Exactly. Okay. Let's do another one. So if you had Thyrofix, 0.25 milligrams by mouth every morning on an empty stomach, available is Thyrofix 125 microgram tablets. How many tablets will the nurse administer for one dose? Okay, so we've got Thyrofix 0.25, that's ordered. And then we have tablets is 125 microgram tablets, okay? And we want to know how many tablets that you would give for one dose. So let's switch it over and see how we do it. So our goal again is tablet per dose, okay? So what we'll do is start with our tablets. This puzzle piece right here has your tablets in it. So tablet over 125 micrograms, okay? And then we've got milligrams right here. We can't put a milligram on top of a microgram. They have to match, remember? So therefore, we'll have to pull out those conversions that we memorized. So if I've got microgram at the bottom, I know I'll need microgram at the top. So 1,000 micrograms is 1 milligram. My micrograms crosses out. And now I can use my puzzle piece with milligrams in it because I have milligrams right here. So 0.25 milligrams over one dose. Milligrams crosses out, and now I'm left with tablet per dose. So that's tablet at the top and dose at the bottom. Okay, so we'll do 1,000. 1,000 times 0.25, which is going to be 250 over your 125. So you divide the top by the bottom and you would give 2 tablets in one dose, or 2 tablets per dose, okay? Is this making sense how we're setting these problems up? Okay. So continuing on. So these are your parental medicines. So medicines that you would give an IV, right? So the healthcare provider orders drug F, 5,000 units, IV. How many milliliters will the nurse administer if drug F is available with a concentration of 2,000 units per 1.5 milliliters? And we're going to round to the nearest tenth place, okay? So y'all let me know in the chat, what is our goal? What is this asking us to find? Okay. I like this way better than when I was taught in school. It's much easier. Okay, awesome. All right, so exactly, we are looking to find milliliters. So that's what we're looking for, right? So what is our order? Our order was 5,000 units. Okay. And then we had available 2,000 units per 1.5 milliliters. So if we're looking for milliliters, guess what we're going to start with? Milliliters. So I'm going to put it on the top. 1.5 ml over 2,000 units. Then I've got units at the bottom, so I need my units to go to the top. So this puzzle piece right here has my units in it. It's not with anything else, it's just by itself. So I'm going to put it over 1, okay? Units crosses out, and what am I left with? Milliliters, which is my goal, okay? It's a matter of remembering the steps of the puzzle. Yeah, so you just start with what you're looking for, then everything else lines up. If you see that every problem that we do, we start with what it is that we're looking for. We write our units to the side and we start exactly with that, right? So 1.5 times 5,000 is going to be 75,000, well, 7,500, excuse me, and then 2,000 units times 1. So we'll divide the top by the bottom, and that's going to be 3.75. All right, here's your chance to practice rounding. If this were asking us to round to the nearest whole number, what would our answer be? Exactly. Uh-oh. 4 milliliters. Okay, so why it would be 4 milliliters is going to be, if we are looking for the whole number, remember we start at the place that we're looking for, that we need to round to, okay? And then we go 1 decimal place to the right. So this number is 5 or more, so that means we raise the score 1 time, right? So that's going to be 4, and then everything else falls off. So 4 milliliters is our answer, okay? So let's do another one. The healthcare provider orders drug N 0.3 milligrams IV stat for respiratory depression. Available is drug N 0.4 milligrams per milliliter. How many milliliters will the nurse administer? Round to the nearest hundredth. Okay, so we're rounding to the nearest hundredth. So what is our goal that we're going to be looking for? How many milliliters, correct? Okay, go. See, y'all are getting it. You're getting it in the chat. Okay. Once you do these, practice gonna make perfect. Okay. So it doesn't come just, 1 or 2 problems. Once you keep doing it, you get the hang of it, you see the verbiage and the wording of the problems, you'll get more comfortable. All right. So we're looking for milliliters. What was ordered was drug N 0.3 milligrams. And then we have available 0.4 milligrams per milliliter. Okay. So if we are looking for milliliters, we are going to start with the milliliters. So that's this puzzle piece right here, and we'll flip it. So we'll do milliliter over 0.4 mgs. Now I've got milligrams at the bottom, so I'll use my milligram puzzle piece right here at the top, 0.3 mg over 1 milligram crosses out, and then we'll divide the top by the bottom. So 0.4 divided by 0.3, excuse me, divided by 0.4, which would be 0.75. So we want to round this to the nearest hundreds, right? So if we're rounding this to the hundreds, there is nothing right there, is it? It's just zero. So this would be our answer, 0.75 milliliters, okay? And everything else was behind it was a zero. Okay, so now we'll do some IV flow rates. How many people are intimidated by IV flow rates? We know that a lot of the medicine that is given to the patients in an acute setting are given in the vein because it gets to where it needs to go and it gets there fast, right? So we need to know how to regulate our flows. So we'll do the same thing. We'll look at the question, read it, find the goal, and we'll set up our puzzle pieces. All right. So normal saline, 500 milliliters, is to infuse over 45 minutes via IV pump. How many milliliters per hour will the nurse administer? Round to the whole number. Okay. So y'all let me know, what is the goal that we are looking for? Okay. We are looking for a milliliter per hour. All right. Okay. So we said we had normal saline, 500 milliliters. So with an IV, we want to know the volume and over the time. So it says that we need 500 ml to go over 45 minutes. Okay. And we need our pump to look like this, milliliter per hour. We've got minutes on the bottom, right? We already got our top goal, which is the milliliter, but the bottom one has to be hours. So if I've got minutes at the bottom, then I need minutes at the top, and I need hours to go at the bottom. And we know that there is a direct conversion between minutes and hours. So 60 minutes is 1 hour. Your minutes crosses out, and now you are at your goal, which is milliliter per hour. So we'll multiply across the top, multiply across the bottom, and divide. So 500 times 60 is going to be 30,000 divided by 45. And that will be all of these sixes. Okay, so if we rounded this to the nearest whole number, our answer would be 667 milliliters per hour. Okay. So as you can see, we're solving the same puzzle pieces and questions, looking for the goal, looking for what we have in our questions, setting it up and crossing it out. Okay. And I'm doing it the exact same way every single time. And we're on, what is this, the fourth different type of question that you would see in dosage calculations. All right. Hopefully it's getting familiar to you. All right. The healthcare provider orders regular insulin, 15 units per hour IV. Regular insulin, 125 units and 250 milliliters of normal saline is available. Calculate the infusion rate as milliliter per hour, and then we're going to round it to the whole number. Okay. So once again, y'all let me know, what is our goal? What are we trying to find here? Goal is milliliter per hour. Okay. So we had ordered 15 units per hour that we were going to give IV. What we had available as the medicine was 125 units per 250 ml. And so what that means is of normal saline is that there is a bag of normal saline and floating around it is 125 units of insulin in there. And we're wanting to see what is the rate that we will set on the IV pump to administer 15 units an hour. Okay. So if we're looking for milliliter, we once again start with our puzzle piece with the milliliters in it. I'm going to flip it because I need my milliliters at the top. So 250 mLs over 125 units. Okay. I'll put my units on the top. So 15 units per hour. Your units crosses out. Both of your puzzle pieces are used. And now what do we have? Milliliter per hour. So you see, we've had something totally different. We didn't even have just regular IV fluids. We added in units with our insulin, and we did it the same exact way. Whatever your units are that's available, you put them on the top, put them on the bottom, cross it out until you get what your goal is. Hopefully it's getting kind of familiar to you. So we'll do 250 times 15, which is going to be 3,750 divided by 125. And that's going to be 30 milliliters per hour. And I see the correct answer in the chat. Y'all let me know, how's it feeling to you? What are you thinking about these puzzle pieces? Because a lot of people said they were intimidated by math. They didn't know where to start. Dosage calculations was, a burden to them. So y'all let me know. Give me some feedback in this chat, okay? All right. So the other way that we can give an IV is going to be in a drip rate. Okay, it's gravity. So instead of using an IV pump, an electronic infusion device, we'll have tubing that's calibrated with different factors of drip factors. A drop factor or a drip factor is the same difference, right? Just the I and the O. Is that there is a chamber, and when you squeeze it, you'll have the solution run down and it will drip down into that chamber. So there, the hole size on the different IV tubing sets will determine how many drops will it take in order to administer 1 milliliter of the solution. Okay, so that's all that a drop factor is. So when you see these drop factors in your question, you can 9 out of 10 bet that it's going to ask you how many drops per minute will you set for your infusion rate. Okay, so what do we have here? An order for 250 milliliters of D5W over 3 hours. So once again, volume over time. How much of this fluid over how long does it take to get into the patient's veins? Okay. So, and we have a drop factor of 10 drops per milliliter. We're going to calculate the flow rate in drops per minute. Okay. So what is our goal here? Drops per minute. Okay. All right. So what we had was 250 milliliters. So that was your volume. Remember, it's got to go over time. So 3 hours. We had a drop factor of 10 drops per milliliter. And then we need to know how many drops per minute. So if we want to know how many drops per minute, we'll start with that puzzle piece that has the drops in it. So we'll do 10 drops on the top, milliliters on the bottom. We've used this puzzle piece. Now we need a puzzle piece that has milliliters in it because I need my milliliters to go to the top, okay? So then we'll have this one, 250 ml over 3 hours. milliliters crosses out, and now we've got drops on the top, but we've got hour on the bottom. We need minutes on the bottom. So now you see how important it is to write your units by your numbers, because you don't know what to cross out, and if you've reached your goal, if you don't know which units to cross out. So we'll do our conversion with time, okay? So 1 hour is 60 minutes. Cross that hour out, and now we've got drops on the top and minutes on the bottom, which is the goal, okay? So we'll do 10 times 250 divided by, what's that, 180? And we will get 13.8 repeating. So with your drop factor problems, you have to round your answer to the nearest whole number, because you cannot divide a drop. You either have one drop or no drops. So because this is a 8 right here, remember, if it's 5 or more, we raise the score. So our answer will be 14 drops per minute. And I do believe I see the correct answer in the chat. Good job, you guys. Hopefully this is making sense. Okay. Now this is my favorite, weight-based, okay? These are going to be similar to your pediatric problems, okay? So the healthcare provider ordered drug D at 15 micrograms per kilogram per minute intravenous infusion. The concentration of drug D, which is going to be dopamine in this case, is 500 milligram and 500 milliliter. The patient weighs 50 kilograms. Calculate the infusion rate milliliter per hour, and we're going to round this to the whole number. Now, you might see this problem and you think, wow, this is a lot of information in here. What do I do? Where do I start? What do I add? What do I not? All right. So I kind of come up with a little mnemonic, PPP, and not the loan that they gave during COVID, but patient. So the patient's weight, prescription, what is your order? And then the product. What is the medicine available? The concentration of it, all right? So what is this question asking us to find? That's the first thing that we must address. We're looking for milliliters per hour. Okay. So patient's weight was 50 kilograms. Our prescription is 15 micrograms per kilogram per minute. And then the medicine itself was 500 milligrams and 500 milliliters. Okay, so if I'm starting with what I'm looking for, I'm going to start with my milliliters. So 500 milliliters over 500 milligrams. My puzzle piece right here has micrograms. I can't put a microgram on top of a milligram, so therefore I got to put in a conversion. So 1 milligram is 1,000 micrograms. Now I've got micrograms at the bottom, so I can put this puzzle piece in. 15 micrograms per kilogram per minute, okay? And now I've got my weight, which is 50 kilograms. I've got kilograms at the bottom, right? So I can cross that out. You see, these puzzle pieces are lining up and they're fitting together. Everything on the top and the bottom have to cross out. And then I've got minutes. I need hours. So finally, I'll do 60 minutes over 1 hour. Minutes crosses out and I am at my goal. And now I can do the math. Okay, so we'll do 500 times 15 times 50 times 60 divided by 500 divided by 1,000. And our answer will be 45 milliliters per hour. Okay. That one was a little bit different. And I think that's one of the harder questions that are in dosage calculations, but it's kind of fun if you've got these puzzle pieces, you're lining them up and you're crossing it out. Will you post the recording on YouTube? Yes, Janice, I sure will. Okay. And then, because our time has been well spent, I'll do one more problem with heparin. Yeah, you're welcome. All right, so a heparin drip, okay? These are two different types of heparin problems. The one that has the heparin drip with the 20,000 units, it's kind of similar to the one with the insulin. I wanted you to see that just because it's not a gram or a microgram or a milligram doesn't mean that it's done any differently. So I'm going to do this problem that's at the bottom that shows you how to have a loading dose and then a continuous drip, because heparin has to have a starting point where it gets into the blood, it starts working, and then that continuous drip is going to keep it at a level that is therapeutic for the patient, okay? So heparin IV at 12 units per kilogram per hour to follow a loading dose of 60 units per kilogram. Available is heparin 25,000 units in 250 milliliters. The patient weighs 189 pounds. How many milliliters per hour will you set the IV pump for the flow rate? All right. So we are going to be looking for the flow rate. So that means that we need that 12 units per kilogram per hour, because the loading dose is also known as a bolus. And you'll see these in the problems that I'll do on Study Buddy Sunday and Work It Out Wednesday. So what we'll use is the information for the drip, right? So what our goal is what? Milliliter per hour, right? And then this is a weight-based problem. So we'll need PPP, patient's weight, the prescription, and then the problem. So our patient's weight was 189 pounds. Our prescription for the drip was 12 units per kilogram per hour. And then what was available was 25,000 units per 250 milliliters. Okay. So what are we looking for? We're looking for milliliters per hour. It's the 60 units extra info. You got it, Brittany, because we're not looking for the bolus or the loading dose. We're needing the flow rate for the drip, right? Exactly. So okay, where we're looking for a milliliter. So we'll start with our milliliters. 250 ml over 25,000 units. Okay. And then we've got units at the bottom. So we'll put our units at the top. So 12 units per kilogram per hour. Units crosses out. And now we're left with kilogram an hour. Hour is part of the goal, right? So it can stay. Milliliter is on top, so it can stay. This kilogram has got to go. So our patient's weight right here is in pounds. So I'll do 1 kilogram equals 2.2 pounds. My kilograms crosses out. And then I'll do 189 pounds over 1 because it's by itself. It's not with anything else. 2 pounds, 2.2 pounds at the bottom. You got your other pounds at the top. They cross out. Everything is now gone except for goal. Okay. And so we'll multiply across the top, multiply across the bottom, and divide. So it'll be 250 times 12 times 189 divided by 25,000 divided by 2.2. And that's going to be 10.309309. Okay, repeating. So if we wanted to round this to the nearest whole number, what would our answer be? I see some correct answers. 10 milliliters per hour. Okay. All right. So I appreciate everybody for taking the time out to come to this webinar. I hope that the information that I have presented to you has been helpful and will be useful for you and your program. If this webinar workshop has helped you or any of my lives, I would greatly appreciate your feedback on my socials. Jakara Lewis, she has texted me and she has made it to Atlanta. So she's getting closer to home. But she does send her well wishes and her regrets that she couldn't come on tonight. But go to her channel. She has a lot of information, useful information for your T's and your HESI. She has all types of math. Like she is the GOAT of math. And she breaks it down. She uses the KISS method. Keep it super simple, okay? So if you're not following me on YouTube and TikTok, Facebook, Instagram, that's where I am. That's where I study on Study Buddy Sundays and Work It Out Wednesdays. Again, this webinar was free. So I hope that you have enjoyed it. I will have the recording on my YouTube channel. So if you would like to view it again, along with other resources that I have, then you are more than welcome to. And I am going to stop the recording now. So thank you.